Okay, here's review exercise 3 for this unit. Below we have the formula for a CDF for a continuous distribution. When you get your answers here, round them to 4 decimal places and put them in decimal form. This CDF is a piecewise defined function. It's 0 for x is less than 5. It's 1 for x is greater than 12. And the important part is in the middle between 5 and 12 for x. And there the y, or the CDF of x, equals x minus 5 over 7, and then take the square root of all of that. Now, first of all, we might convince ourselves that that actually is a legitimate CDF. That's the first thing we might do. And then we could maybe go ahead and then compute these probabilities and inverse probabilities. Notice A, B, and C are probabilities. Well, the rest of them, D through G, are inverse probability problems. See if you can work these out. I'm going to probably in one screen show you all of the answers to these things. So take your time, work all of these out carefully, each one, and then once you have all your answers written down, come back to the video and check your work. Press pause now. Okay, actually here are all the answers, so let's go through this. So I'm actually going to do this on a TI-84 here. So anytime I give you a formula, probably the first thing to do is put in the formula. Now this part where where y is 0 and the CDF and y is 1, that part's really not that important for us. So we will not really worry about that part. So what I'm going to do is take the other part and put it in my calculator. So square root of, let's see, parentheses for the numerator, x minus 5. Close parentheses, divide by 7, close parentheses for the square root. Now, if you've got the newer operating system, which I do here, you could also actually make it look almost exactly like this by going to, so I'd have to turn on Math Print. And I go down here to put the square root, and then I can go to a fraction by doing alpha F1. Press the first one, that gives me a fraction, and now I don't have to worry about the parentheses because the horizontal fraction line is a grouping symbol and the square root works all over that. So either one of these are exactly the same thing. Okay, so if I look at the table of these, no change, no difference. So either one of those works just fine. Let me just use the original one there. Okay, so put that in there. You got to figure out an appropriate window. Well, this right here tells us 5 to 12. So we go from 5 to 12 for this one. That's the only part where this formula actually applies. Now there's a way to make this actually graph correctly as a piecewise defined function, but it's just not worth the effort. Basically, you want the y's to go from 0 to 1. I went a little bit below and above that. Spread that out a little bit from negative 0.3 to 1.1. And marked it off in 0.1s. And so we get a graph. Okay, and here's how you can tell if it's a legitimate CDF. It should start at 0 and go up to 1 on this interval. To the left of this is 0. To the right of this it's 1. And so there we get it. It's one connected piece. All the y's are on or above the x-axis. And it increases from 0 on the left to 1 on the right. So that is a legitimate CDF. Now to find probabilities, we can do this really from the home screen. And we want to find the probability that x is less than 7. So that's y1 of 7. So if you've got an older calculator, you're going to have to do it this way. Variables, right arrow to y variables, function, y1. Of 7, like that. If you have the newer operating system, which I recommend, you can just go to alpha trace, which is F4, and select y1 from there. So you could do y1 of 7 that way. And round off to however many places it says, in this case 4, so that's 0.5345. Probability that x is greater than 9. Okay? Well, that's 1 minus y1 of 1 minus the CDF of 9. So it's 1 minus y1 of 9 because y1 has our CDF formula, 0.2441. Between 6 and 8, well, that's the CDF, that is Y1, evaluated at 8, minus the Y1, CDF, evaluated at 6. To do an inverse probability, what you do is we want to put, well, this one is the easy enough algebra here. You could actually put the 0.1 on this side here and solve the resulting equation for x. But a way we can do it if that's not possible, or even if it is and we just don't want to mess with it, is we can put the probability to the left here, which is 0.1, and graph that, and it graphs a horizontal line. And what we're looking for is where these two cross. So you can go second trace, which is calc. We want to do number 5, the intersection. First curve, enter, second curve, enter. And now we just use our arrow key, left and right, to get over close, pretty close to where they cross, and hit enter, and that gives us our intersection. So 5.07 is the A value. When they give you the probability to the right, you don't put in that number, you put in 1 minus that number, which is the probability to the left. I can either go ahead and do this in my head or with the calculator ahead of time and know that that's 0.95, or I can just put in 1 minus 0.05. Again, we want to do a calculate intersection, number 5. First curve, just hit enter. Second curve, hit enter. And for the guess, use your right or left arrow to get close to where they cross. Doesn't have to be perfect, but kind of close. Enter, and there's the x value that we're looking for. And of course, the y value is the 0.95, which is the probability to the left. So the distance this horizontal line is from the x-axis is 0.95. The distance it is from y equals 1 is the 0.05. Now the median is the same kind of problem. It's an inverse problem, but we know the probability to the left is 0.5. So otherwise it works just exactly the same way. We want to calculate the intersection of that CDF curve with the line at y equals 0.5. So enter, enter, and there's our guess. 6.75 is the median. The 45th percentile, okay, that would be 0.45 here. If it said the first quartile, that would be 0.25. If it said the third quartile, that would be 0.75. If it said the 7th decile, that would be 0.7. So in either way you go, it's the probability to the left, or the proportion that's to the left. Again, we just do a calc intersect, which is really just solving this equation. Okay? So enter, enter, and then we'll go over here and enter. This is, once again, this is equivalent to putting the 0.45 on the y here and say it's equal to the square root of x minus 5 over 7. In this case, we could square both sides, multiply by 7, and add 5, and we would get the same thing. In fact, let me show you that. There's the x value. We came up that way. And if you solve that equation, like I said, you would put the value here, square both sides. So you take the 0.45 and square it. Then you would multiply by 7 and then add 5. 6.4175. 6.4175. If you want to, you can say math and enter a couple times if you'd rather see it as a fraction. Okay, so that's how you can do probabilities and inverse probabilities on a calculator with when you're given the formula for the cumulative density function, when you're given a formula for the CDF.